Okay, so welcome to Regular Chemistry Unit 1, Learning Target 3 on scientific notation. And in this learning target, I'm asking that you be able to understand how to use scientific notation to convert units from standard form to scientific notation, and also to perform some calculations. So you should probably remember scientific notation from previous science courses and, of course, your math courses as well. In chemistry, one of the most important numbers that we use is expressed in scientific notation, and it's this number right here, 6.022 times 10 to the 23rd. It's called Avogadro's number, and the significance of this number, if you don't remember from Science A, is that this is the number of particles or atoms or molecules in a mole of something. So it's a way to count things, just like there are 12 in a dozen, there are 6.022 times 10 to the 23rd in a mole. Now you can see below that this number is expressed in standard form, and that's a whole lot of zeros to write. What are the chances that you might make a mistake and either omit or add an extra zero? Probably pretty high. So scientific notation is used to express very large or very small numbers, such as Avogadro's number. So again, what's scientific notation? It's a way for us to express really large numbers or really small numbers that are typically written with lots of zeros. One of the benefits is that it's more concise. Obviously, if you go back and see, this is much shorter than this. It also reduces the chance of adding or omitting an extra zero. Scientific notation, of course, consists of two parts. You're going to have your first part here. This is your number between 1 and 10. It's called your mantissa. It's a new word for you today, I bet, mantissa. And then you have the power of 10 behind it. So mantissa times something to the power of 10. It cannot be 10. You can't have a number greater really than 9.99 or so. All right, so what does scientific notation actually mean? Let's take a look at the number 800. Okay, 800 is actually able to be expressed as 8 times 10, which would be 80, times 10 again, which is 800. So 10 times 10 is 10 to the second. So 8 times 10 to the second is 800. You can also have numbers that would have decimals past, or digits past the decimal. 2.531 times 10 would be 25.31. Times 10 again would be 253.1. Times 10 again gives you the original 2,531. So this is another way to express that. You can also have numbers that are less than 1, and instead of multiplying now, you're dividing by 10. And so in this case, we have the tenths, the hundredths, and the thousandths place. So we're going to divide by 10 3 times. All right, let's review on how to change a number from standard form to scientific notation. Here we have the number 381 million. The first thing we want to do is place the decimal so that there is only one non-zero digit in front of the decimal. In this number here, do you see a decimal? Well, you don't visibly see one, but there is one that's implied right here behind the 0. We want to move that so that it's here between the 3 and the 8. Okay, next we're going to count the number of decimal places that the decimal point has moved from the original number. This is going to be your exponent. So if you have commas, you can count by 3s. This is 3, 6, 7, 8. So it's going to be something times 10 to the 8th. Now, to figure out the mantissa, you're going to look, and in most cases, just keep the digits that are not zeros. 3.81 times 10 to the 8th. Now, we need to talk about the sign of the exponent. If your number is greater than 1, you're going to have a positive exponent. If your number is less than 1, it'll be negative. So do you agree that this number is larger than 1? Yes, so we have a positive exponent here. All right, let's do some problems here. We have 289,800,000. The decimal is right here. We want to move it between the 2 and the 8. So 3, 6, 7, 8 spaces. So it's going to be something times 10 to the 8th. And we have 2.898. We're going to keep all of those non-zeros there. Okay. The next number. We have an implied decimal here behind the last 0. We're going to move it 3, 6, 9, and one more, 10 spaces. So it's going to be something times 10 to the 9th. And here we just have 2 non-zeros, so this is simply 4.5 in the mantissa times 10 to the 9th. Both of these have positive exponents because they're numbers that are larger than 1. All right, now if we get down here to this number, what do you notice about it? It's smaller than 1. So we're going to move our decimal from here so that we have 1 digit in front of the decimal. That means that the decimal is going to go here between the 5 and the 6. 1, 2, 3, 4. It moved 4 places. So this is going to be times 10 to the negative 4th because this number is less than 1. Then your mantissa is simply going to be 5.67. You're going to keep these 3 non-zeros. And the decimal is here between the 5 and the 6. All right. And this next one, notice how I've left spaces between the zeros. You'll commonly see that in textbooks or sometimes on worksheets because it's not conventional to use commas in numbers that are less than 1. So here we have a number that's really small. We're going to put the decimal right here between the 4 and the 5 because we want just 1 non-zero in front of that decimal. Now we're going to move the decimal 3, 6, 9, 12. And so this is going to be something times 10 to the negative 12th. It's negative because this number is less than 0, and the mantissa is going to be 4.567. Okay. Next, how do you deal with a problem where you have to change scientific notation to standard form? You're going to move your decimal point to the right if you have a positive exponent of 10, and move the decimal point to the left for negative exponent of 10, and you can also use zeros to fill in the spaces. Something that I find really helpful is to use a number line. I'm going to draw it for you here. Okay? Imagine that this is 10 to the 0. Okay? -1, -2, -3, -4, -5, -6, +1, +2, +3, +4, +5. All right, let's say that you have a number like, and this is really helpful with negatives, so I'll just make up a number here. 3.8 times 10 to the negative 4th. Okay? That means that your decimal is right here. Which way do you move your decimal? Well, you're going to our decimal is right here, and we're going to move it 1, 2, 3, 4 spaces. So 1, 2, 3, 4, and then you fill in these empty spaces with zeros. So it would actually be 0.00038 as the way to express 3.8 times 10 to the negative 4th in standard form. All right, so here are some examples. We have 5.093 times 10 to the positive 6th. We know that this number is larger than 1 because it has a positive exponent. So I like to sometimes rewrite it 5.093 so that I have room to move my decimal. 1, 2, 3, 4, 5, 6 spaces. I'm going to fill this in with zeros. This now becomes 5,093,000. Okay. The next one is also a positive exponent, so we know that this is larger than 1. I'm going to rewrite my mantissa so I have space to move my decimal over here 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put your decimal there and fill it in. Okay, let's count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And we can put commas in here. So this is 2,780,000,000. Move some of these out of the way, but I've run out of room. Okay. Next, we have a number that has a negative exponent. That means that it's less than 1. So we know it's going to be 0.0 something. So here, with the 1.44, we're going to move it back 5 spaces. 1, 2, 3, 4, 5. We're going to fill it in with 1, 2, 3, 4 zeros. 0.0000144. Also, in front of a decimal, you generally put a 0. That's just a conventional way to attract the eye to know that there's, there's your number starting with a decimal, essentially. Okay, the last one is also a number that's less than 1. It's a very, very small number because we have -9 as the exponent. So if we have 3.85, we're going to move this back 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we should have 8 zeros there. 1, 2, 3, 4, 5, 6, 7, 8. So point 1, 2, 3, 4, 5, 6, 7, 8, 3, 8, 5. Okay. All right. Next, how should you use your calculator to express a number in scientific notation? This is actually where students will make mistakes on something that's really relatively easy. Okay, there are 2 major brands of calculators that you're probably going to be using in this course. In my classroom, the bulk of my calculators are these Casios right here. But I also have some Texas Instruments. They may not be the 30X. They might be something else. Or you might have a Texas Instrument as well. So I'm going to show you both ways. If you use a calculator, you will use the EXP button, which is found right here on most of the Casios. If you use a Texas Instrument, you're going to be looking for the EE button, or sometimes it's 2 lowercase e's. They mean the same thing. And this one, it happens to be right above the X to the -1st, so you're actually going to have to do Shift and then press that button in order to get the EE to show up. Okay? When you press the EXP or the EE button, you need to say to yourself, times 10 to the whatever. Okay? So let's try this. We know that 45,000 in standard form is expressed as 4.5 times 10 to the 4th. I want you to see that on your calculator, if you enter this in correctly, it'll show up as 45,000. So what I want you to do is, with your calculator, type in 4.5 and then press EXP or EE, depending on what type of calculator you have. And that's going to mean times 10 to the, and then you're going to enter in your exponent, which in this case is a 4. So in your mind, you should be saying 4.5, and then as you enter in your EXP or your EE button, times 10 to the, and then 4. Now, do not do the following. Do not try to push the 10 caret button. I know that some of the Texas Instruments especially have that option. Don't do it. That will put your answer off by a factor of 10. So instead of getting 45,000, you might get 450,000, or you might get 4,500. You do not want to be off by a factor of 10. That's bad. Okay, next let's talk about some rules for operations in scientific notation. We can do these most of the time without a calculator, and then I'll show you how to do them, of course, with a calculator as well. So when you are multiplying something in scientific notation, first you want to multiply the mantisses, and then you're going to add the exponents. So when you multiply, you add the exponents. Okay, so here let's multiply 3.2 times 10 to the -7th by 2.1 times 10 to the 5th. First, you're going to multiply your mantisses. 3.2 times 2.1 is 6.72. Then you're going to add your exponents. Negative 7 plus 5 is negative 2. So this is 6.72 times 10 to the negative second. Okay, here, try this one by yourself. 14.6 times 10 to the 7th by 1.5 times 10 to the 4th. Okay, when you multiply these out, you'll see that these exponents, 14 times 1.5 is 21.9. And then you have times 10 to the 7 plus 4 is 11. Now, is this number expressed correctly in scientific notation? No, because we have too many digits in front of the decimal. So we're going to move our decimal over one more space, and that adds to our exponent. So now this becomes 2.19 times 10 to the 12th. So remember to make sure that your answer is expressed correctly in scientific notation. Remember that when you're dividing in scientific notation, you're going to first divide the mantisses and then subtract the exponents. So when you are dividing, you subtract the exponents. Okay, first we have 6.4 times 10 to the 6th divided by 1.7 times 10 to the 2nd. 6.4 divided by 1.7, do your mantisses first, is 3.76. All right, then we're going to subtract our exponents. 6 minus 2 is 4. So 3.76 times 10 to the 4th. Okay, next try this one. 2.4 times 10 to the negative 7th divided by 3.1 times 10 to the 14th. All right, if you divide your mantisses first, 2.4 divided by 3.1, you'll find that it's something like 0.774. And then times 10 to the negative 7 minus 14 is negative 21. Is this number written correctly in scientific notation? Nope, we're going to have to move the decimal over one more space. This becomes 7.74 times 10 to the negative 22nd, because we've made the number more negative, so we're adding an exponent. All right, let's do some practice here. First, without a calculator. All of these numbers are really simple to do without a calculator, and then you can verify it with a calculator. In the first one, we have 3.0 times 10 to the 3rd times 2.0 times 10 to the 6th. And so to make it simpler for you to see it this way, first thing we're going to do is multiply our mantisses. What's 3 times 2? 6.0. Now, we are multiplying in scientific notation, so what do we do to the exponents? We add them. So this becomes times 10 to the 9th. 3 plus 6 is 9. Okay, next, we have 5.0 times 10 to the 4th times 2.0 times 10 to the 9th. What's 5 times 2? 10. So our mantissa right now is 10. That should raise a red flag to you. Hey, I've got too many digits past the decimal. I'm going to have to go back and fix this in a minute. Okay. Now let's add our exponents. 4 plus 9 is 13. So initially this is times 10 to the 13th, but we've got to fix this mantissa. We're going to move our decimal over one place. This is now 1.0 times 10 to the 14th. Good. All right, next we're going to divide. First, we're going to divide our mantisses. What's 5 divided by 2? 2.5 times 10 to the, now we're going to subtract our exponents. What do you notice is happening here? 6 minus 8. Good, negative 2. Okay, so you can have a negative exponent. And then, of course, 4.5 divided by 2 is going to be 2.25 times 10 to the, now subtract your exponents, 3 minus 2 is 1. Okay. Lastly, adding and subtracting in scientific notation. I think this is slightly more challenging even than multiplying and dividing. In this case, you have to have the same power of 10 before you can do anything. So, same power of 10. Here we have 5.8 times 10 to the third, and we want to add it to 2.16 times 10 to the fourth. Do they have the same power of 10? No, this one has a 3 and this one has a 4. So what I like to do is try to get it to the one that generally has the smaller exponent, or the one closer to 0. So we'll keep 5.8 times 10 to the third, and then we're going to go ahead and convert 2.16 times 10 to the fourth to 21.6 times 10 to the third. So we're going to move this decimal back over 1, and then that takes the 4 to a 3. So now we have 21.6 times 10 to the third. Now we can add 21.6 plus 5.8 times 10 to the third. The powers of 10 remain the same. Just bring them down. Times 10 to the third. 6 plus 8 is 14. Bring down your decimal. 6, 7, 2. So 27.4 times 10 to the third. Now, is that number expressed correctly in scientific notation? Nope. Got to move the decimal back over. 2.74 times 10 to the fourth. Okay, so you can see that there's some added work there. In most cases, you can use your calculator, and so I wouldn't spend a whole lot of time agonizing over doing this by hand, but I do want you to understand that they do have to have the same power of 10 in order to add them. Okay, I want you to try this one by yourself, and then see if you get this. You can use your calculator for it. All right, that concludes Learning Target 3. You should now be able to complete your homework on adding and subtracting, multiplying and dividing, and expressing numbers in scientific notation.